Chapter 6, Problem 4.2. Now we are looking at three sinking objects. We have the density for each object. All of those densities are larger than the density of water, which shows that they are all sinking. They all have the same mass, but they have different volumes because they have different densities. So first we are asked to calculate the volume of each object. We know that density is mass over volume. Therefore, volume is mass over density. For the first one, we find a volume of 0.952 cubic meters. If we do the exact same calculation for the second one, we find a volume of 0.833 cubic meters, and for the last one, 0.625 cubic meter. Now, how much water was displaced by the object? Here the objects are fully submerged. So the volume of displaced water is the total volume of the object. So there is no calculation to do. They are simply equal. Now if I want to find the mass of the displaced water, I multiply the volume by the density of water, which is 1,000. So I multiply the volume by 1,000 to obtain the mass, which gives me 952 kilograms, 833 kilograms, 625 kilograms. So what I notice, and I can actually see that on the diagram at the top, is that the less dense object displaces more water than the denser object. All those objects have the same mass, therefore they have the same Fg. In order to calculate Fb, I multiply the mass of the displaced water by G, and for G I use 10 meters per second squared, which gives me an Fb of 9.52 kilonewtons for the first one, 8.33 kilonewtons for the second one, and 6.25 kilonewtons for the last one, keeping in mind that 1 kilonewton is equal to 1,000 newtons. So now the Fb is no longer balancing out Fg. They are different and Fg wins. Fg is larger. That's why the objects sink to the bottom. So we can calculate the difference between Fb and Fg, and this will be the net force acting on the block before it reaches the bottom. So this is before reaching the bottom. When they reach the bottom, of course, they reach static equilibrium, and the normal force from the bottom of the lake comes into play. But on the way down, we can calculate this by doing Fg minus Fb. For the first one, in kilonewtons, we get 0.48. For the second one, negative 1.67. And for the last one, negative 3.75. The negative meaning they are all down. The net force is down, as expected. Again, this is for a block sinking on its way down to the bottom before it reaches the bottom.